Welcome, everyone, to the Deep Dive. Today, we're diving right in, headfirst into a topic that honestly used to feel like climbing Everest for me.
Yeah.
How to break into the world of artificial intelligence, especially if you're coming from a completely different background, We're drawing on some incredible insights today, the real-world journey of someone, let's call them Alex, who is exactly where many of you might be right now. A complete beginner who went on to build a tangible AI project from scratch. So our mission for this deep dive is to unpack how a practical project, specifically house price prediction, can be your ultimate learning ground for AI. And crucially, how to make that hard work truly shine on your resume.
Yeah, and what's truly fascinating about Alex's journey is that this isn't just theory, right? We're going to walk you through the actual steps, the inevitable bumps in the road, and the rewarding triumphs. Someone who genuinely moved from zero to successfully predicting house prices using machine learning. It's a perfect real-world example of applied knowledge. It shows you how you can build something valuable, even as a beginner.
Okay, so let's unpack this straight away. Why house price prediction? I mean, why is that such an ideal first project for someone just dipping their toes into AI? What makes it stand out?
That's a really important question for any learner, actually. How do you know you've grasped the theory? And the answer, like Alex's experience shows so well, is through a practical project. House price prediction, and while it really shines for maybe 3 key reasons, it's particularly beginner-friendly and impactful. First, think about data accessibility. For so many AI projects, just getting clean, relevant data is like 80% of the battle. It's a huge blocker for beginners. But with house prices, you can often find really good stuff on platforms like Kaggle or government open data portals. It's kind of like having all the ingredients prepped for your first big recipe. You can jump straight to the cooking, the learning part.
Right, you don't get stuck just trying to find the ingredients.
Exactly. Second, it has a crystal clear real-world application. Everyone gets what house prices are, what influences them. It's relatable, not some abstract concept, so the why behind the AI is immediately clear. You get the real-world value. You're not just, moving numbers around. You're solving a problem people actually care about.
Yeah, that makes sense.
And third, it's an absolute resume superpower. Look, anyone can take an online course, get a certificate, and those are great. They build a foundation, but building something? That tells an employer you can take theory, get your hands dirty with real, often messy data, troubleshoot problems, and deliver a tangible result. It shows grit, initiative. No certificate alone does that quite the same way. For Alex, this project was that first moment of like, wow, I actually built something valuable with AI. That feeling, it validates everything.
That resume superpower point really hits home, makes the abstract feel concrete. But speaking of concrete, what about the nuts and bolts? The actual process. For someone starting from square one, how do you even begin? Can you really predict house prices from scratch?
Oh, absolutely. Alex's journey really broke this down nicely. 4 fundamental steps, basically, and they're designed so anyone can follow along. Step 1 is data collection. Simple enough, right? Find your data. Alex started on Kaggle, searched house prices dataset, looked at government real estate data too. The initial amount of data isn't the most critical part. It's making sure it's clean. This is so important and often overlooked. Transforming inconsistent formats, making tables uniform, and critically, deleting obvious errors, like you see a house listed with 1 ping that's maybe 30 square feet, or 0 price. That's clearly wrong data.
Right, garbage in, garbage out.
Exactly. Quality over quantity right from the start. Step 2 is feature selection. This is about choosing the characteristics, the features that you think impact house prices. Sort of like, what would a real estate agent add?
Okay, like size.
Yeah, size or ping count. Location, is it in a certain area near the MRT? Building year, obviously the age. And house type, apartment, detached, villa, whatever. Those are your features.
Okay, now here's where you said it gets really interesting and where I've seen beginners get tripped up. You mentioned avoiding fields that would leak the answer. Can you explain that? It sounds a bit like cheating.
It absolutely is like cheating. It's called data leakage. Imagine teaching a kid algebra, right?
Yeah.
And you accidentally give them the answer key to the test.
Yeah, they'd ace it, but learn nothing.
Precisely. So if your data set had a column like total price evaluation value, and you use that as a feature, your model would just look at that column and go, oh, that's the answer. It makes the prediction trivial, meaningless. It doesn't learn the relationships between size, location, age, and the price. It just finds the shortcut.
Okay. That's a really common trap, I bet. Gives you fake good results.
Totally. Results that won't work on new, unseen data. Step 3 is model building. Now, for beginners, Alex's advice is start simple. A linear regression model. Think of it like trying to predict prices using just one straight line, finding the best fit.
Okay, basic bit gets you started.
Exactly. Once you're comfortable, then you can move to more advanced models. Random forest, XGBoost. If linear regression is one straight line, think of these as drawing hundreds of tiny, flexible lines or even complex webs. They capture more complex patterns, nonlinear stuff that a single line would totally miss. Often gives better performance. And the great thing is, Python's scikit-learn library makes this surprisingly easy. It's very beginner-friendly.
Okay, model built. What's next? How do you know if it's any good?
Right. Step 4 is model evaluation. You need to assess performance. The main metrics you'll hear about are RMSE, root mean squared error, and MAE, mean absolute error. Think of them as your error budget. MAE tells you, on average, how many dollars you're off by. Simple, direct. RMSE, though, it penalizes bigger errors more heavily.
How so?
Because it squares the errors before averaging. So if your model is way off on just a few houses, RMSE will be much higher. It screams louder about big mistakes.
Ah, okay. So it tells you about the really bad predictions.
Yeah, it helps you understand not just if you're wrong, but how badly on those outliers.
So it's not just about getting those numbers, RMSE and MAE, as low as possible then. Connecting this to the bigger picture. What else do you need to check?
Exactly. It's not just the raw numbers. This is crucial. You must check for overfitting.
Overfitting?
Yeah.
That's when it works too well in the training data, right?
Precisely. It performs exceptionally well in the data it learned from, but then poorly on new, unseen data, the validation set. It basically means the model just memorized the answers for the training data instead of learning the general patterns.
So how do you prevent that, or at least check for it?
You use cross-validation. Think of it like serious exam prep. Instead of just one practice test, you break your study material into, say, 5 parts. You study with 4, test on the 5th, then rotate. Study with 4 different parts, test on the remaining 1. Repeat 5 times.
So you're testing it on all parts of the data eventually, but never on data it trained on in that specific round.
Exactly. It ensures your model isn't just good at one specific test, but truly understands the material. Gives you a much more reliable score of its real-world performance. It's essential. Make sure your model isn't just a one-trick pony.
That makes so much more sense.
Oh.
Okay, laying it out like that seems pretty manageable. But we know learning isn't always smooth sailing. What were some of those bumps in the road Alex hit? The real-world challenges.
You're absolutely right. Challenges are where the real learning happens sometimes. Confidence comes from tackling them. Alex ran into 3 pretty common hurdles. Challenge 1 was incomplete data. Real-world data sets are messy. Missing values everywhere. Maybe no building year listed or missing size data. The ping counts.
Yeah, what do you do then? Seems like a dead end.
It can feel like it. Alex learned 2 main ways to handle it. Either fill the gaps, impute them using simple methods like the median or average value from the data you do have. An educated guess is often better than nothing. Or if a column has too much missing data or some rows are just too problematic, sometimes you just have to remove that column or those rows.
Pragmatic choices, not perfection.
Exactly. Make the data usable. Challenge 2 was unstable model performance. Especially early on, just using the default settings for a model, you might run it, get a result, run it again, get a totally different result. It's super frustrating.
Yeah, it makes you doubt everything.
Right. The solutions. 1 is hyperparameter tuning. That's like fine-tuning the model's internal knobs and dials, like how many trees in your random forest, or the learning rate in XGBoost, optimizing those settings. And the other, as we just talked about, is using cross-validation again.
So cross-validation helps stabilize things too.
Definitely. Validating across different data splits gives you a much more stable, reliable measure of performance, clearer picture of what your model can really do.
Okay, incomplete data, unstable performance.
Mm-hmm.
What was the third challenge? You mentioned something often overlooked.
Yeah, challenge 3, and it's huge. Mental anxiety.
The self-doubt.
Totally. Especially if you don't have that traditional computer science background. I remember when I was first learning, staring at code, thinking, am I even cut out for this? It's a real barrier. Alex faced questions like, will this simple model I built be seen as worthless? Can I even do this? It can be paralyzing.
So what was the breakthrough? How did Alex push past that?
The breakthrough insight, and it's so powerful, was finish first, then optimize.
Finish first, then optimize. I like that.
It's about fighting that perfectionism trap. Getting any result, even a simple, imperfect one, builds confidence. It builds momentum. It proves to yourself, hey, I can actually make this work. And that first success fuels you to learn more, refine it, make it better. Sometimes just getting a messy, working version out the door is the biggest win.
That's such a great piece of advice, honestly, for learning anything new. So, okay, You've done the hard work, built the project, learned a ton, battled the anxiety, gained confidence. Now the resume part. How do you actually present this effectively so it stands out?
Right, making it count. Alex's experience points to 3 critical things to include for maximum impact. First, clearly state the project goal. Simple, concise. Establish a machine learning model to predict house prices. Immediately tells them what problem you solved. No guessing.
Okay, clear goal. What's second?
Second, list your technical tools. Be specific. Python, Pandas, Scikit-learn, XGBoost. Even if they seem basic to you, list them. It shows practical implementation experience. Recruiters scan for these keywords.
Got it. Tools used. And third,
and this is absolutely key, highlight specific results. Quantify your achievements. Don't just say completed project. That's weak. Say something like Alex could. Model prediction error RMSE was 1.2 million, outperforming baseline models by 30%.
The numbers. Concrete proof.
Exactly. Quantifiable results are way more persuasive. They show impact. They show what you actually achieved. And hey, for extra credit, put your code on GitHub. Transparency is impressive. Maybe create a short report or some slides summarizing it. Shows communication skills. Or even share your learning journey on LinkedIn. Those little extras, they can really make you stand out.
That's fantastic, really practical advice. This whole deep dive has made building an AI project feel much less daunting. So what's the final piece of wisdom? The key reminder for someone listening right now, feeling maybe a bit like Alex did at the start.
I think the most important reminder based on Alex's journey and so many others is this. You don't need to master every single model, every single theory before you start doing. So many people, especially maybe without that formal tech background, fall into this trap, wanting to read every book, understand every concept perfectly.
Analysis paralysis.
Just exactly. They get stuck consuming information, never actually producing anything. Just remember, the project itself, that is the best way to learn. It forces you to tackle real problems, deal with messy data, debug errors, find solutions, often by looking things up as you go. Start simple. Get something working, even if it's clunky. Then iterate. Optimize. Step by step, you'll look back and realize you've learned way more, gained more practical skill and confidence than just reading ever could. It really is about doing.
That's a perfect note to end on. What a truly insightful deep dive into practical AI for beginners. We've seen how a project like house price prediction can really demystify AI, build skills, boost your career prospects. And that idea, finish first, then optimize, honestly, that applies everywhere in life, doesn't it? So if this deep dive has sparked your interest, if you're thinking about starting your own AI project, don't hesitate. Find a topic, grab some data, and just get started. And let us know, what AI project are you most eager to tackle? We'd love to hear about it. Next time, we're going to continue this thread. We'll share a curated list of AI learning resources, books, courses that can help you navigate the journey, hopefully avoid some common pitfalls. So don't miss that. Be sure to subscribe so you catch our next deep dive. And please share this with anyone you know who's curious about breaking into AI. Until then, keep learning.